And we're live. We're live with Bilal Ben Mahria. He is a knowledge graph architect with over 7 years experience working with knowledge graphs, metadata management, linked data, and semantic technologies. Bilal, it's a pleasure to have you. You're calling from Morocco, right?
Yes, yes. Thank you, Juan, for having me today here. I really appreciate that. Thank you.
Yes. So if you need anything, you should be fine. Let me. I'll be in the background.
Okay, thank you so much. Okay, so uh, let me start directly from yeah here. So good morning, good afternoon, good evening, everyone. Thank you for joining today's session on knowledge graphs and their organizing principles. In fact, my name is Bilal, and I'll be discussing the differences between property graphs, taxonomies, and ontologies, their benefits and limitations, how to choose the best organizing principles for your needs, and the potential for combining these three organizing principles to build a robust knowledge graphs. So let's get started. In fact, today I'm delighted to discuss the evolution of knowledge graphs, focusing on the changes before and after 2012, the challenges and consideration in building them, and the demonstration of context-aware academic retrieval enhanced by various technologies is just a demo about how we can use graphs with LLMs in order to improve the academic research area. So let's begin by exploring how the concept of knowledge graphs has evolved over time. But before that, let us just give you a context, okay, about the knowledge graphs. So in fact, knowledge graphs, okay, the first question that people or the first thing that people need to know is the following: the knowledge graph is something that we can use in order to make our data smarter. Okay, so in fact, rather than having repeatedly encode smart behavior into applications in the logical layers, now we can encode the logical layer in the data itself. Okay, and now we can build smart dump in fact applications and smart data layer. So and this smarter data in fact enables knowledge use and reduce duplications and discrepancies. Okay, so when building this or when decide to make this data smarter, we need to use a knowledge graph, and we rely on certain organizing principle to structure our data effectively. And the three main principles are property graph, taxonomies, and ontologies. And each has unique characteristic and serves different purposes depending on the complexity requirement of the data representation. So let us start by just, I like, in fact, to be honest, I like history. I like to see the evolution of the things. So let us just start to understand the knowledge graph before 2012. So we can start by 1970s, okay, where foundational works in instructional systems have advanced teaching methodologies by using directed graphs for visualizing content. And this is what we can see in the work that Schneider published. And then Comil create a numerical representation of tracking knowledge and the performance. And after that, Markey and Miguel use the game theoretic in order to improve the courses by including the interactivity in a learning. So all these contributions combine visualization, quantitative analysis, and interactivities. And after that, we have the period of 1980s. In this period, okay, we have Rada, the person that lead the groundwork for advanced decision support in healthcare, understanding complex interactions and structuring knowledge. And Then Jarkey introduced the knowledge graphs for managing and visualizing software project knowledge. And then in 1990s, the definition of knowledge graph is refined by including the term taxonomy of instances and classes. Okay, and then after that, Mercado and Freitas introduces a cyclic weighted terms to define graph in order to improve the process of decision modeling. Okay, and then we can jump directly to thousands, okay, where people developed plain knowledge graphs for organizing strategies, for strategic planning using knowledge graphs. And then we have the period of 2010s when people enhanced systems ability to provide coherent explanation for output and decisions. And then the last one, it was Corby and Faron Zakar, where they emphasized knowledge graphs role in representing complex relationships and facilitating data retrieval and inference domains. So here we can understand that each area, in fact, has its own a specific definition. So in 1970s, you can find people see a graph, it's simple directed graph diagram to represent Schneider's work. What does that mean? It's representing the instructional courses and these things. And then in 1980s, we have the weighted graph term. And then in 1990s, people start to use the term taxonomy. And then in 2000s, people start to use knowledge graphs without the awareness of the knowledge graph, using just flowchart in order to organize things inside organization. And then in 2010s, the term conceptual graph start to appear in order to combine the conceptualization with the term graph. Then after 2012, we have just 5 categories, okay, of defining a knowledge graphs. People here define a knowledge graph in the category 1. We have the simplest and the most directed definition of knowledge graphs. Here, a knowledge graph is viewed as graph where nodes are entities and edges are the relationships between them. This simple structure is sufficient for many applications, especially in the field of knowledge graph embedding. However, it raises crucial questions. For example, how is a knowledge graph different from the traditional graph or plain old graph? And where exactly does the knowledge come into play? And then we have in the category 2, where the category 2, in fact, takes further by defining a knowledge graph as a graph structured knowledge base. So here, the term knowledge graph and knowledge base was used interchangeably, and this definition connects to the older concept of the knowledge base. Okay, and then we have the category 3, and we have here in the category 3, we have the technical definition. The knowledge graph is something that we can use in order to represent the reality. We have nodes, we have relationships, and also here Paul Haim and in fact Bilal Marini saw that it's important to include the reasoning capabilities in the knowledge graphs. But in fact, this definition, although it provides solid technical foundation, but may not always align with practical applications, because it's not necessary to include reasoning capabilities into your knowledge graph to see that I'm using knowledge graph. And finally, we have the category 5. It's the category where we can define a knowledge graph by example. So instead of strict definition, it highlights well-known knowledge graphs like DBpedia, Google, Yago, Freebase. This is practical approach, helps us understand what a knowledge graph is by looking at existing examples, but it does not provide precise definition. Okay, now after that, so now that we understand what a knowledge graph is and have seen its evolution over the time, let's move on to discuss how to build this knowledge graph and determine the best organizing principles for structuring here. In fact, there are 3 main organizing principles: property graphs, RDF graphs or ontologies, and taxonomies. But before talking about that, let us just focus on plain old graph, so something that is old. So in the difference between a plain old graph and the knowledge graph is that the interpretation of the information in plain old graph is encoded in the system that uses the graph, rather than being a part of the data itself. And this can be a problem. Why? Because in the plain old graph, the interpretation of the information is embedded within the systems that use the graph rather than being a part of the data itself. This can causes problem for newcomers. For example, a data scientist with no previous knowledge of the domain may struggle to perform analysis such as basket analysis to find out which products are purchased together. For example, in this graph, we have the node P, we have the node A, but and we have the age, but we don't have any background knowledge about what is the kind of this P and A and what they represent. Okay, so since it's not evident from the nodes and the relationships alone, we always need people in order to explain to us this graph, and this is where we can put ourselves in the risk of knowledge loss. Because if the person who created the graphs leave the organization, the new user would have to reverse engineer the algorithms to interpret the graph because all the logic behind the graph is embedded in the application. Now, after that, yeah, what is the organizing principle? So generally, the organizing principle provides a contract between a graph and its users, but this contract does not only apply to humans, it also applies to software. And let us start now to check what is the first organizing principle. The first organizing principle is the property graph. Okay, you can see this. Okay, this property graph where we have the nodes, these nodes connected to the edges, but compared with the plain old graph now, we have the nodes with the labels, we have the edges with the types, and each node has its own characteristic, and also the edge, also we can represent the characteristics of the edge. So here we can understand that in this property graph, we can say the following. The property graph makes a graph self-describing. So I don't know, I don't need to rely to people in order to understand exactly what is embedded in this graph. And this is it to be considered like a first step toward making data smarter. And now I can, for example, as data scientist or as data engineer, I can understand that if I want to extract all the papers, I have here a node that is called paper that I can use. But even though with the knowledge, the property graphs also can have a lot of problems. And in fact, the limitation of the property graphs are the features, are not limitations. From my point of view, are the features. For example, the property graph don't have a formal semantics, which means they lack standardized way to interpret the meaning of the node. And also, for example, sometimes the property graph, it's hard to work on the problem of the interoperability in the property graph level, because we don't have any vocabulary, we don't have any standardized technologies in order to solve the problem of the interoperability in the layer of the property graph. And this is something that hard to achieve with property graphs. And also the flexibility of for the schema flexibility. So the flexibility of schema, it's not always an advantage, okay? Because sometimes the flexibility of schema can be a limitation in scenarios requiring, for example, strict data validation and consistency. And property, and then we have, for example, the knowledge representation limitation, because knowledge graph, the labels and the edges are only the tags in order to tell us the role of the nodes and nothing else. And then if we want to achieve the data provenance and traceability, it's hard to do that with a knowledge graphs, a property graphs, sorry. So here we need stronger organizing principles, and we can start, for example, with the taxonomy. So taxonomy, in fact, as we can see in the labeled property graph, labels are only the tags, okay? And these labels can only tell us the role of the node in the graph. So there is no associativity between the labels. What does that mean? There is no associativity between the labels. You can't, for example, infer that, for example, something is specialized for another thing. So in order to represent the inheritance relationships, it's hard in property graph, because the labels are only tags that we can use in order to see or to mention the role of the nodes. So, and the absence of associativity between labels is considered to be in fact feature, okay, not a bug, because type systems and polymorphism are in application level concern. So keep in mind that labels are not types with inheritance characteristics. They are indicators of nodes role in the graph. This is why we need something that can use in order to improve the 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 expressivity of our graph. This is why, for example, here in our scenario, in the academic, for example, this is just small part of a graph, okay, where we have decided to add a skill taxonomy. This skill taxonomy can be helpful. Why? Because if the end user want to find an expert in the field that is work on RDF, OWL, and Sparkle technologies, okay, as we have already included our taxonomy in this graph. So if the end user typed I want RDF expert, and as I have Bilal is has a research of interest semantic web, and semantic web has a narrower and the children as RDF, so I can recommend to people, for example, some expert based on that, based because this based on the skill to skill taxonomy. Okay, so uh, this taxonomy can structured skill categorization, okay, that can give us a good overview about categorizing the authors, and also they can improve the data consistency, okay, why because the skills taxonomy can ensure terminology and classification of skills, which reduces ambiguity and improving data quality across the graph. Okay, and then also by linking authors to a detailed skill taxonomy, it's possible, for example, to use this skill taxonomy in order to highlight and create comprehensive profiles that highlight authors' expertise, proficiency levels, and potential areas for growth. Uh, Okay, now as you can see, the taxonomy represent only the collections of topics with subcategories, parent-child relationships, our classification type that we can use in order to group set of instances together and give them a label. But in fact, in order to increase the level of expressivity of the graph, we need to jump into another organizing principle, that is the ontology. Ontology also, it could be considered like taxonomy, but in addition to that, it can define more complex relationships between categories. Now we can define relationships like, for example, part of depends on based and using formal semantics. And this can has a big benefit, like provide a richer associativity between between the nodes. So the ontology, in fact, can give to our graph, okay, another level of expressivity where we can use the reasoning capabilities. So if you have a requirement that rely on using reasoning capabilities, you want to rely on the ontologies in order to do that. So yeah, so this is what I was seeing. So we need a vertical and a horizontal exploration. Ontologies can ensure the reasoning with ontologies, and also the ontologies can solve the problem of data integration in a good way and in accurate way. Then finally, I want just to share with you this table. The table is coming is adopted from the OntoText website. Okay, so I will also only focus on the last two points: the main use cases and the data management strength. In effect, if your requirement only need graph analytics and the path search. So the property graph in this case, it's good. Okay, we can still in this level of expressivity. But if you have the problem of knowledge representation, metadata management, and so on, this is something it is hard to achieve using the property graphs. And then also for the data management use cases, because ontologies can provide to us some powerful keys that we can rely on in order to solve the problem of interoperability, like for example the global identifier and standard schema. This is something that we can't find, for example, in the property graphs. And then finally, just I want to share with you um, like a demonstration. Okay, it's just I want here to share my screen just to show you uh, how, for example, the property graph combined with the knowledge with the LLMs can provide to us a good result. So let me just share my screen. Can you confirm that my screen is shared?
Yep, it's
Yeah,
being shared
yeah.
properly now.
Okay, good. So this is just an application, small application that we are working on in order to help people to find, for example, expert, to write, for example, some words in order to find the expert that or the researchers that they are working on this field. For example, here I have prepared an example. Like for example, I want to find abstract with for example RDF, Sparkle, and Owl. Okay, so here I can find, for example, some abstract that can use these terms, and here we are using cosine similarity in order just uh, to give an insight to the user that this abstract is similar to what you want based on this score. And then if I want, for example, now to find what are the authors that I can collaborate with, I can extract from my graph I can extract from my graph the authors. Okay, like for example, for each abstract, this is the set of authors that we can collaborate with find in order to find the expert that or the person that I want to talk to or that I want to collaborate with. So for example here, I want to take this, for example, as an example. Okay, and I will see, I will tell to my service, please recommend to me the co-authors or the collaborators that Bilal or Oki can collaborate with. So and with the threshold, I hope that it works. Yeah, it works. So here, this is the data is coming from our laboratory, and we can see that, for example, I can collaborate with this person with the similarity of one based on skills. Okay, because I have already added the taxonomy of the skills in my property graph, where I and this person, for example, shared same skill set. Now I can, for example, I can decide that I need to, for example, communicate with this person in order to collaborate or just ask her questions or so on or so on. So there are top 10 collaborators that I can deal with. Okay, and yeah, okay, okay. So in the conclude to conclude, in fact, just I want to say something. The definition, there is no standard definition of the knowledge graphs. So the definition of knowledge graph is related to the context where people want to use the knowledge graphs. So for example, definition of knowledge graph based on the ontologies, it's different on the definition of the knowledge graphs based on the property graphs, because people, when they decide to use ontologies, they have in mind that they want to use to solve the data management problems. They want to use the resonant capabilities and so on. But for example, if my use case it's only the data analysis, or for example machine learning based graphs, it's sufficient, for example, to rely on the property graphs on to cover this need and to solve all my questions. Here just some resources that I have used in order to build this presentation. And please, if you have any questions, please.
Yeah, this is fantastic. What a multifunctional skill set and knowledge you need to have to be able to develop a properly structured knowledge graph. I think you said something very insightful. There's no unified definition of
Yeah,
knowledge graph.
yeah,
So everybody that is developing with these kinds of technologies
yeah,
does not adhere to a strict standard, right?
mm,
People use standard technologies from W3C, but they don't stick to a
yeah,
quality or enterprise checklist to
mhm,
say there's a taxonomy, there's an ontology,
mm,
there's a validation, there's
mm,
verification in these
yeah,
areas.
yeah.
So for somebody who's starting out and they want to get involved with the first organizing principles, what would be your recommendations for that?
Uh, Start simple. Okay, what does that mean? If you want to start building a knowledge graph, just start with property graphs. Okay, just start simple. Why? Because based on my experience, I encountered a lot of customers, okay, where they explained to me their need, okay, they only need a property graph, but someone recommended to them, for example, the ontologies or something. But the ontologies, it's complex system, to be honest. Okay, so why do I need to build ontology where I will not use its characteristic, like for example reasoning capabilities, like for example the horizontally and vertically relationships. Okay, so what I want to say to people is that start simple. Start with property graph. If the property graph does not answer your questions, inject in this property graph, for example, a taxonomy, and see how this taxonomy can improve the property graph. And then, but at the same time, if you have clarity about that, I want to use, for example, reasoning capabilities. My problems need to be, and also if my problem is the semantic data integration, don't think about property graphs. It's very hard to achieve the data integration in the property graph layer because why? Because the property graphs don't have a unified schema that we can rely on in order to, yeah,
That was going
to
to be
define.
my follow up. So
Yeah,
initially you're suggesting do property graphs because there's a lower learning
yeah,
curve and it's a limited functionality.
yeah,
But here's the case: when people buy into a solution, they kind of dig a trench because they have to learn the platform, learn the language, learn how to implement it, and then they kind of get used to it based out of comfort. But what about when they need to extend it for concentric use cases? Like you have the first use case that you start out internally with, and then you say, okay, now we want to integrate this to an external data source, open link data source,
yeah.
or we want to integrate this to another aspect of our organization. Wouldn't that then encourage you to begin with ontologies and standards from the beginning? I mean, I guess it depends on the resources and
Yeah.
the motivations, right?
Yeah, 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 exactly, exactly. It depends on the requirement, Juan. Okay, why? Because the key here, we need to be careful, okay, when we want to analyze the customer's requirement. Okay, uh, we need to give a title to the problem. This is you can give a title to the atomic problem, like for example, is it a data integration problem, is it machine learning based graph problem, is it, for example, a classification problem, okay, something like that. So if you have the clarity about the kind of the atomic problem that you need to solve, okay, you can select the most appropriate organizing principle. As I said before, if the problem is a semantic data integration, you need to jump to the ontologies. Don't waste your time in the property graph. Why? Because we have standard vocabularies, we have schema, we have a unified framework.
What about the people that don't know anything? I just like as an example, I hear about semantics yesterday,
Yeah,
and today, I asked for a small budget of like $10,000 or something ridiculously low, and I say, I want to play with semantics. How do I begin to build the problem scope? How do I begin to articulate the use case? If I have no experience or knowledge of this stuff.
in fact, based on this in fact budget, okay, you need to just rely on guidance of a domain expert. Okay, why? Because it's important here to rely on the guidance of the domain expert in order to point yourself to the appropriate place. Okay, here if you can put yourself in the appropriate place, okay, like for example in the first layer, in the second layer, or in the third layer, you can, for example, use this budget in a good way, and you can exploit this budget and don't waste it in something that you don't want to do. Okay, so here the domain expert, it's something that you can rely on in order to put yourself in the field. And this is one of the questions that we need to answer, in fact, Joaquin, using our application. Okay, I need to start with RDF recommend to me, and currently we are working on integrating this graph with the Microsoft Academic Graph. Okay, in order to make it international, and people can start, for example, searching for experts to connect with, to communicate with, in order to gain time and to build a good career. Yeah,
Fair enough. Okay.
yeah.
Well, Bilal, thank you very much for the presentation. One last question. We still
Yeah.
have a few minutes. For the taxonomy, where do you begin with that? How do you, in a nutshell, how do you begin doing that in the lightest form?
So, do you mean related to the application?
Yeah, when you say, okay, I have a property graph that I'm playing
Yeah,
with. It's the cheapest
yeah.
way to get involved with developing a lightweight knowledge graph
Uh,
representation. Where do I begin to develop that taxonomy?
Yeah, so now you are asking what is the need and the thing that makes me and pushes me to develop and add a taxonomy layer. Exactly, good. This is a good question, because if, for example, if I have an expert has a research of interest, it's, for example, semantic web. Okay, here I can start here. Okay, now the end user come and, for example, ask my system question, give me all people that use RDF. You can see that I don't have any RDF now, because I only have semantic research, the research of interest, that is a semantic web. Now, here, I need to add skills to the research of interest. Like, for example, semantic web has narrower, okay, skills like OWL, RDF, and, for example, Sparkle. Now, this taxonomy can help me to recommend to the user, for example, and improve the good result and improve the hierarchy of the organizing principle by injecting the classification schemes, because taxonomies are classification schemes. So now if I ask, give me people that use RDF. RDF is connected to semantic web technologies. So I can, for example, start to give to people good recommendations. Another point also, it's skill to skill relationship. I can, for example, add relationships like RDF is complement of Sparkle, for example. Okay, and this, if I can build skill of skill taxonomy, that can help me in order to not only recommend to people profiles, but only create profiles for these people and recommend to them some areas where they can contribute in future.
Well, I think that gives some food for thought. Bilal, thank you very much for the wonderful presentation.
Thank you.
We're going to take a small break and then we're going to get on with the next one. We're going to be talking about the proof of concept with graph rag. So you might be interested in that one.
Okay, okay, okay. You're welcome.